Interested parties, including members of the electrical industry, consumers, and the general public, can make comments on proposed changes to the National Electrical Code. To comment on the NEC, firstly visit the National Fire Protection Association, or NFPA, website. Secondly, submit comments through the NFPA comment portal. For other codes, check the website of the code-making organization for specific instructions on how to submit comments. Regarding an exception for multiple breakers on multi-wire branch circuits, the 2023 NEC contains an exception in section 210.4b3. This exception states where the branch circuit supplies only one utilization equipment and the other conductor of the multi-wire branch circuit supplies only that utilization equipment, a single-pole circuit breaker with a handle tie shall be permitted. This exception applies to the scenario you described, where one side of the multi-wire branch circuit supplies a furnace and the other side supplies a general-purpose circuit. In this case, a single-pole circuit breaker with a handle tie would be permitted. Therefore, the proposed change to require multiple breakers on multi-wire branch circuits does not apply to this particular scenario. Let's delve into the details of multi-wire branch circuits and the exception provided in the NEC. A multi-wire branch circuit consists of two or more ungrounded conductors with a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit and which is connected to the neutral or grounded conductor of the system. Multi-wire branch circuits are commonly used to provide both 120 volts and 240 volts in residential settings, or 120 volts and 208 volts in commercial settings from a single circuit. The purpose of using multi-wire branch circuits is to save on wiring costs by sharing a common neutral conductor. However, they also present certain safety concerns, which is why the NEC has specific requirements for their installation and protection. One of the main concerns with multi-wire branch circuits is the potential for overloading the neutral conductor. If the loads on each leg of the circuit are unbalanced, the neutral conductor will carry the difference in current between the two legs. If this current exceeds the ampacity of the neutral conductor, it can overheat and potentially cause a fire. To prevent this, the NEC requires that the neutral conductor of a multi-wire branch circuit be sized to carry the maximum unbalanced load. Another safety concern with multi-wire branch circuits is the possibility of losing the neutral connection. If the neutral conductor becomes disconnected, the voltage on each leg of the circuit can become unbalanced, potentially damaging equipment connected to the circuit. To prevent this, the NEC requires that multi-wire branch circuits be provided with a means to simultaneously disconnect all ungrounded conductors at the point where the branch circuit originates. This is typically accomplished by using a 2-pole or 3-pole circuit breaker. Now, let's discuss the exception in section 210.4b3 of the 2023 NEC. This exception applies to situations where each ungrounded conductor of the multi-wire branch circuit supplies only one utilization equipment. In other words, each leg of the circuit is dedicated to a single appliance or piece of equipment. In this case, a single-pole circuit breaker with a handle tie is permitted, instead of a 2-pole or 3-pole circuit breaker. A handle tie is a device that mechanically connects the handles of 2 or more single-pole circuit breakers so that they trip simultaneously. This provides a similar level of protection as a 2-pole or 3-pole circuit breaker by ensuring that all ungrounded conductors of the circuit are disconnected at the same time. The reasoning behind this exception is that, in this specific scenario, the risk of overloading the neutral conductor or losing the neutral connection is reduced. Because each leg of the circuit is dedicated to a single piece of equipment, the loads on each leg are more likely to be balanced. Additionally, the equipment itself provides some level of protection against voltage imbalances. It's important to note that this exception only applies if each ungrounded conductor of the multi-wire branch circuit supplies only one utilization equipment. If either leg of the circuit supplies multiple outlets or appliances, then a 2-pole or 3-pole circuit breaker is required. Let's consider some examples to illustrate how this exception works. Suppose you have a multi-wire branch circuit that supplies a furnace on one leg and a general-purpose receptacle on the other leg. In this case, the exception would not apply because the general purpose receptacle could be used to power multiple different appliances. Therefore, a 2-pole circuit breaker would be required. However, if you have a multi-wire branch circuit that supplies a furnace on one leg and a dedicated air conditioner on the other leg, then the exception would apply. In this case, each leg of the circuit supplies only one utilization equipment, so a single-pole circuit breaker with a handle tie would be permitted. It's also important to consider the specific requirements of the local electrical code. Some jurisdictions may have additional requirements for multi-wire branch circuits which may be more stringent than the NEC. For example, some jurisdictions may require that all multi-wire branch circuits be protected by 2-pole or 3-pole circuit breakers regardless of whether the exception in section 210.4b3 applies. In addition to the requirements for circuit breakers and handle ties, the NEC also has specific requirements for the wiring of multi-wire branch circuits. For example, the NEC requires that the grounded conductor of a multi-wire branch circuit be identified by a continuous white or grey marking. This helps to ensure that the grounded conductor is properly connected to the neutral busbar in the electrical panel. The NEC also requires that the ungrounded conductors of a multi-wire branch circuit be identified by different colors. This helps to prevent accidental short circuits between the ungrounded conductors. The NEC provides a table of recommended colors for ungrounded conductors, but other colors are permitted as long as they are clearly distinguishable from each other and from the grounded conductor. When installing multi-wire branch circuits, it's important to follow all of the applicable requirements of the NEC and the local electrical code. This will help to ensure that the circuit is installed safely and correctly, and that it will provide reliable power for the equipment it serves. In summary, multi-wire branch circuits are a useful way to save on wiring costs, but they also present certain safety concerns. The NEC has specific requirements for the installation and protection of multi-wire branch circuits, including requirements for circuit breakers, handle ties, and wiring. The exception in section 210.4b3 of the 2023 NEC allows for the use of single-pole circuit breakers with handle ties in certain situations where each ungrounded conductor of the circuit supplies only one utilization equipment. However, it's important to carefully consider the specific requirements of the NEC and the local electrical code before installing a multi-wire branch circuit. Furthermore, when dealing with electrical installations, it's crucial to consult with a qualified electrician who is familiar with the NEC and local codes. They can ensure that the installation is performed safely and in compliance with all applicable regulations. Ignoring these safety precautions can lead to hazardous situations, including electrical shocks and fires. Always prioritize safety and seek professional assistance when working with electricity. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Regulations and codes can vary, so it's essential to stay informed about the latest updates and requirements in your area. Regular training and continuing education are also important for electrical professionals to stay up to date with the latest industry standards and best practices. By adhering to safety guidelines and seeking expert guidance, you can ensure that electrical installations are safe, reliable, and compliant with all applicable regulations. Remember, electricity is a powerful force that should be treated with respect and caution.